All right, today we're going to be talking about solving inequalities. Before we've solved equations, so now we're going to move on to a single-step inequalities and multi-step inequalities. We have a couple key concepts. I'm not going to spend a lot of time on them because they're a little bit wordy for what we need. I wrote some notes down here at the bottom. Nothing changes for adding and subtracting. A plus C and B plus C. Notice the symbols are the same. Greater than with greater than, less than with less than. Greater than with greater than, less than with less than. Nothing changes. All right. It's this next one that we have to be a little more aware of. So let's look at the next one. Multiplication and division. This is where we have to flip the sign when we multiply or divide by a negative. So here, greater than, less than, less than. Nothing changes when it's positive. But look at what happens when it's negative. It goes from greater than to less than, and less than to greater than. We changed the sign. We flipped it. And the same thing happens down here with division. That is the most important thing that you need to understand about this solving inequalities. It's just like solving equations, except you have to flip the sign when you multiply or divide by a negative number. All right, let's look at some examples. Let's start with something that's a single step here. We have 12 is greater than negative 0.3p. So that is a multiplication there. So to get rid of that multiplication, we are going to have to go ahead and divide. So there's your original equation. We're going to go ahead and divide by that negative 0.3. And notice, since we're dividing by a negative number, what happened to our sign? It ended up flipping. So it's now less than instead of greater than. P is negative 40 is less than or equal to P. And we're going to probably flip this around just so it looks a little bit nicer. So P is greater than negative 40. All right. Now we're going to take that, and we do want to graph our solution on a number line. Inequalities are better on a number line. When you have an equation, it is an exact answer like negative 40. But to show that it's more than just negative 40 because it's greater than negative 40, that's what an inequality is, we put it on a number line. So that way it accounts for all the points that we're dealing with. So here we go with a number line. Now, greater than or equal to, remember, because of the equal to sign underneath, it is a closed-in dot on negative 40. So we have a closed-in dot here because it's including, because of the equal to sign. Remember, if it's not, we have an open circle. But it's closed in, greater than, where are the numbers that are greater than? That's to the right. Notice how the symbol kind of tells you which way it's going. Greater than. That only happens when P is at the beginning. So it kind of goes this direction and it goes off to the right because those are all the numbers that are greater than negative 40. All right, let's try a multi-step one. So now let's solve an inequality of 3x plus 7 is greater than 22. So we subtract 7, and remember, for addition and subtraction, nothing changes. So plus 7, minus 7 to both sides to get rid of that plus 7. 3x is greater than 15. I did not change anything. Then we're going to divide by 3, and that 3 is positive. So since the 3 is positive, we're going to go ahead and not switch it again. So it's just x is greater than 5. Again, it's not inclusive, so we have an open circle and going off to the right. Now, what if we have a bunch of steps with variables on both sides? We can move it to either side, and we should be able to go ahead and solve this correctly no matter which side we go to. But we like positive, so we're probably going to just take the 4y and move it underneath the 5y. But you could do it either direction, and you'll get the same answer. So minus the 4y, so that just gives us 1y. We still have this plus 2 over here. We have to go ahead and move it over. So we minus 2. And y is greater than negative 5. Again, we're going to flip this around so it looks a little bit nicer. Y is greater than negative 5. And then we go to our graph. Because it's a greater than, we're going to have an open circle on negative 5. And we're going to go off to the right. We can even use this concept in the real world. So here's a typical type of problem that we could go ahead and worry about. Javier has at most $15 to spend today. He wants a bag of pretzels and a bottle of juice for $1.59. If the gasoline at the store costs $2.89 per gallon, how many gallons of gasoline can he buy? So we need to set up some sort of equation so we can go ahead and figure out how many gallons he can buy so he doesn't go over, because because that's all he's got. He's got 15 bucks. So let's set our variable G, number of gasoline. Total cost is 2.89 times G. If you want to make that an X, that's fine. It doesn't really matter. We just need a variable here. And it's 2.89 because that's the price per gallon. And the cost must be less than $15 because that's all he's got. Less than or equal to, he could be exactly on 15. So let's take a look at this. So we need to write our inequality. We got the cost of the juice and pretzels and the cost of the gasoline, and it has to be less than or equal to 15. So let's fill in things. The cost of the pretzels is 1.59 plus, obviously, the cost of the gasoline is a multiplication, less than or equal to, because we can have exactly 15 and $15. And it's just a matter of going ahead and solving this equation. We're going to have to get rid of this, $1.59. So subtract that from both sides. And then we're just going to take the amount of the cost of the gasoline, and we're going to go ahead and divide it. And we get 4.6. So he can fill up his car for 4.6 gallons. And that's all I have for you today.